Platform Analytics provides for advanced analysis of HPC data, including jobs, resources, licenses, and more. In this module, I'll look at the Workload Statistics dashboards. This dashboard shows information about the state of jobs and resources across our clusters. Each graph represents the number of job slots in various states on average over a selectable time period. I see that the UK cluster has the largest number of pending jobs waiting for job slots. I can see how many jobs on average were pending over a period by placing my mouse over any chart. The number of pending slots actually overwhelms running slots. I'll exclude pending slots and just focus on other slot states. I'll fast forward and do this. By excluding jobs pending assignment to slots, our scale changes. I see the relative number of slots running on average across the different geographies, shown here in green. I'll reintroduce pending slots into my analysis and look at a time-based representation of slot usage by selecting the Workload Utilization tab. Now I see a time-based view. In the top slot capacity chart, I see the average number of slots in each state and how they changed over the course of a week. I'm looking at slot counts over the periods as averaged each hour. We know from the previous view that most pending jobs were on the UK cluster, but pending job counts aren't consistently high. On April 11th, we had worked down most of the pending job backlog, but after this the backlog began to climb again. Presumably jobs were submitted faster than they could be processed. I can select different dimensions and measures on the lower chart. Presently we're looking at total CPU time by project across all the clusters. Let's focus on just the UK cluster, where you'll recall we had few running job slots on average. This cluster has less capacity in terms of available slots. This is part of the reason so many jobs are pending. In the lower chart, projects are color-coded by their project ID. I see there's a single project that accounts for most of the CPU time consumed overall. I'll reintroduce other clusters into this analysis. I'd like to see how CPU runtime is broken down by cluster around the world. To see this, I'll modify the dimension from project and change it to cluster. This analysis shows the difference between CPU time and elapsed time. In the UK, despite the smaller number of job slots, the workloads shown in orange are actually consuming more real CPU time overall. The UK activities account for most of the CPU time globally, in fact. This and the large number of pending job slots suggests that they are under-resourced. I'll change the report options and focus only on running jobs. Now the top chart shows the average number of job slots in a running state, whereas the bottom chart shows the CPU time consumed. As you'd expect, the two measures are correlated. We see a similar shape to each graph. I'll look at running jobs by project. I can focus on the project consuming most of the CPU time by placing my mouse over the corresponding project color on the lower chart. This is project 19. I'll filter the data to look at statistics related only to this project. Now we'd like to know what users were working on project 19 and understand the breakdown of CPU time by user. A few users shown in red, green, and blue account for most of the activity on the project. This pattern shows me that different users are busy on different days. Recall that we're still filtering to show only running jobs tagged to project 19. Let's see what clusters these particular jobs are running on. By changing the dimension back to cluster, I see that most of the running jobs in this project are running on the UK cluster, shown in orange again. I'll include all projects in the analysis once more. And I'll include all slot states again. And finally, before I move on to looking at slot capacity data, I'll change the dimension back to project. I want to leave it set this way because in a moment I'll want to see workload statistics by project once more. I'll move on to the next tab and look at information about slot capacities. This view shows me the number of slots in various states on average day over day. As you'd expect, the total available slots remains fairly constant, but there's a lot of variation in the number of running and pending job slots. I can drill down and look at variations in slot status by the hour. This tabular representation can be easily exported for more analysis. I'll move on to the Workload Data tab. Recall I'd left the workloads broken out by project earlier, so I'm seeing the hourly breakdown of running job slots by project here. I'll return to a daily view instead of an hourly view. It's easy to see how we can examine individual projects and readily gather data for capacity planning or project-based accounting. Before I wrap up, I'll look at the raw data on which all these different workload statistics views are based. I'll select the Data tab. In this view, I can filter data by date, cluster, host status, queue, or user. I'll look at just the US cluster. Now I see data for all US jobs broken down by job slot, status, project, and queue, and ultimately by user. I'll focus on just running job slots. As the administrator of the US cluster, I might want to see how my resources are being used by jobs originating only from remote geographies. I have an import queue that acts as a container for these incoming jobs, so I'll look at just this queue. Now I see details about remote users running jobs on the cluster. I see the projects as well as the individual users working on those projects. Resource use is broken out by slot time consumed, the average number of slots in use, as well as total average CPU time and memory consumed. When I use this view to focus on topics of interest as I've done, this new view of the data will also be represented automatically in the other tabs. To illustrate, I'll select the cluster summary again. And here I see just the running jobs in the US submitted to the cluster via the import queue. Let's quickly review what we've seen. The Workload Statistics dashboards help me understand global workloads, capacity and demand, and how both are trending over time. With clear visibility to workloads and infrastructure, I can plan capacity more effectively. I can also make sure I'm sharing optimally between geographies. By tracking statistics by user, project, and queue, I can quickly identify and address bottlenecks affecting productivity. I can also make sure that projects are resourced as intended and that SLAs are being met. And finally, with easy access to so much accurate information, it becomes straightforward to implement usage-based accounting so that costs can be spread across departments based on actual resource use. I hope you've enjoyed this overview of the Workload Statistics dashboards. Thanks for your attention.